Alright, so in this video we are going to be going over solving quadratic equations. Okay, so quadratic equations in general can be solved by using different methods. So we're going to go over 3 different methods. The first method we're going to be going over is what we call the square root property, and I'm going to show you when to use this one. The second method is what we called factoring and the zero factor property, so those go together. And then the third method, which you already might be familiar with, is using the quadratic formula. All right, so let's go ahead and start with the first one. So the square root property is shown below. Again, it looks very scary. Don't let it freak you out. We use the square root property, and I'm going to tell you exactly when to use it. When you have a single variable that can be isolated. And I know that makes no sense, right? But we're going to show an example. So what you do is that if you have an x squared that can be left by itself, you leave it by itself in one side of the equation, and then you put everything else on the other side. So in this one, it's just an a. Now, to get rid of a square, what you do is that the square root property says that the opposite of a square is a square root. So you square root this side. What you do to one side, you do it to the other. These two cancel out, so you're just left with x. And then on this side, you're left with the square root of a. Now, every time you do a square root, always put a plus and minus in the front. Okay, that is pretty much the square root property, and we are going to be doing several examples right now. So again, just make sure you always remember you square root both sides, and your square root can always be positive or negative. If you forget that sign, you're only going to be left with half an answer. All right, this is what your problems are going to look like, right? Here, you open up your homework, you open up your test, you see this problem. How do you know you can use the square root property? This is how you know. In the whole problem, there's only one variable, which is m, and it's being squared. Nowhere in the problem do you see another m. That's how you know you can use the square root property. So what we're going to do first is we have to isolate the m. We have to leave it by itself. So what I'm going to do is that 180, I'm going to move it to the other side. So if I do that, this is what I get, right? It's a positive 180. If it goes to the other side, it becomes a negative 180. That's what you do. We can still not, or we still cannot use the square root property, right? I cannot square root both sides because there's still a number in front of the m. So since it's being multiplied, I'm going to do the opposite. I'm going to divide both sides by -2 so that my m can be left by itself. Of course, it's still going to have a square, right? But it's going to be by itself. So if I divide both sides by -2, negative 180 divided by -2 is 90. Now look at this. The m is left, or it's by itself on one side of the equation. So now I can apply the square root property. I square root this side. I square root that side. Please do not forget, every time you do a square root, remember it's a plus and a minus. These two cancel out because a square is the opposite of a square root. And I'm left with m equals plus or minus 90. Now, this answer is fine. It's perfectly correct. This is my final answer. But on your homework, you are going to be required to simplify a radical or a square root. So a square root has to be simplified. If you put this in your calculator, you're going to get a decimal. That's not what I want. I want the square root of 90 super simplified. So what you can do, and one of the methods that we use to simplify a square root, and if this method does not work for you, just reach out to me and I'll show you a different method. But what you could do is you could ask yourself, okay, is 90, or can 90 be divided into two numbers where one of them has a perfect square? So the answer to that is yes, and that is how I get my final answer. And you're like, oh my goodness, what happened? Let me show you. So 90, the square root of 90, can actually be rewritten as 9 times 10. Right? 90 is actually 9 times 10. The reason I like those two numbers is because 9 actually has a perfect square root. What's the square root of 9? 3. So what you do is that the square root of 9 is 3, so I take out the 3. And 10 is not a perfect square root, so I just leave it inside. So you see how I got my two answers? That's it. And of course, since there's a plus and minus, one of them is plus, the other one is minus, and those are my final two answers. That wasn't that bad, right? So again, when you reach this point, ask yourself, is 90 a perfect square root? If it's not, break it down into two factors where one of them is, and that's how you simplify your answer. All right, let's go ahead and try one more problem here. Again, you see this problem. How do you know you can use the square root property? Because there is only one variable. There's only one y. There's no more y's on the problem. Of course, the y is being squared, right? There's a number in the middle, but that's okay. This is how you know you can use the square root property. Now, in order to use the square root property, whatever is being squared, which is all of this, is being squared, has to be left by itself. So that means I'm going to have to get rid of this negative 2. So what I'm going to do is I'm going to add 2 to both sides. So I added 2. I know, please do not judge my ugly 2. So there we go. These cancel out. 34 plus 2 gives me 36. And now whatever is being squared is left by itself on this side. Now, since both of those numbers are being squared, please do not get rid of the 4. I have to get rid of the square because everything here is being squared. How do I get rid of a square? I square root. What I do to one side, I do it to the other. Again, you do plus and minus, don't forget. So the square and the square root cancel out. And I'm left with, I'm sorry about this. Pretend this is a y. I magically changed the variable, I'm sorry. So this becomes y plus 4 equals plus and minus 36. Now in this problem, we know the square root of 36. The square root of 36 is 6, right? So we're going to break this down into 2 problems. Okay, please do not freak out. And again, I'm so sorry about this. These are still y's, so just pretend these are y's. Now, why in the world is there 2 different problems? Again, because the plus and minus. 36, the square root of 36 is 6. So we're going to write the problem 1 with a positive 6 and then 1 with a negative 6. Just like the last problem, we're going to end up with 2 answers. Now you're just going to solve these separately. So in order to solve this problem, I'm going to subtract 4 from this side and also from this side. And my final answer is going to be y equals 6 minus 4 is 2. And again, I'm sorry, that's a y. And then on this side, I solve it actually the same way, right? Minus 4 and minus 4. These two cancel out. But on this one, since the 6 was negative, negative 6 minus 4 actually gives me negative 10. Okay? So that's it. That's how you use the square root property. And again, we only use the square root property when we have only one variable throughout the whole problem. There's only one y in here. If there was another y on the other side, we would have to use a different method. All right, so here is the second method we're going to talk about. This one is called factoring and the zero factor property. This one, we are going to use it like like I just warned you on the last slide, when we have a variable that appears more than once throughout the equation. So again, this makes no sense. Don't worry, just write it down and then we're going to do an example. So what this method says is that when you have a polynomial or an equation, right, that has the same variable appear more than once, you have to make sure that your equation is equal to 0 first. It has to be equal to 0. So you might have to move things around. Now, what you're going to do after that, you're going to factor it out like this. You're going to write like this, factor it out. And again, that's why we went over factoring first. And then once you have it factored out, all you do is that you're going to get the first factor. You're going to set it equal to 0. You're going to get the second factor. You're going to set it equal to 0. And then you're just going to solve these, and that's how you're going to get your answers. Okay, so let's go ahead and give that one a try. So this is what the problem is going to look like. Again, on this one, we cannot use the square root property because the x appears more than once. So that's a dead giveaway of, hey, you cannot use the property you were using earlier in the video. So what we're going to do is we're going to have to use the factoring and zero factor property. But remember, the zero factor property can only be used when the equation is equal to 0. In this one, my equation is equal to negative 12. But you should be like, ma'am, I can fix that. Of course we can. We're just going to move the negative 12 to this side and voila, we're going to be left with a 0 here. So if I move the negative 12 to that side, it becomes a positive 12 and problem solved. Now this is equal to 0. Now what we're going to have to do now is factor this out. So we're going to have to factor this out. And again, you should be an expert on this already. In order to factor this out, remember how we learned earlier, this is a trinomial. So I have to find two numbers that multiply to 1 times 12, which is 12. And they add to the middle number, which is negative 7. So those two numbers are negative 4 and 3. Negative 4 times 3 gives me 12. Sorry about that. Yeah. And then when I add them, gives me negative 7 here. All right, once you find those two numbers in there, and I'm actually sorry about this. This is actually supposed to be a negative 3. Okay, negative 4 times negative 3 gives me positive 12, and negative 4 plus negative 3 gives me negative 7. So again, you see I also make mistakes. So just make sure, please, that this is a negative. So x minus 4 and x minus 3. All right, now after this, once it's factored out, remember what factoring a trinomial does. Remember, after you find those two numbers, you divide them by the number in the front, but the number in the front here is 1. So if I divide these two numbers by 1, it's not going to do anything. It's just going to leave them like that. So we're almost done. Once you factor it out, you get the first parentheses. You set it equal to 0. You get the second parentheses, and again, this is a minus. I'm sorry about that. You set it equal to 0, and then you just solve them. So how do I leave x by itself on this one? I move the 4 to this side, and it becomes a positive 4. So one of my answers is going to be x equals 4. And then I solve this one. How do I solve this one? I move the negative 3 to this side, and it becomes a positive 3. So my final answer for this one is 3. So look at that. That's how you solve these problems. This is what we call factoring and the zero factor property. Okay, so use, oh my goodness, I did not meant to do that. I'm sorry. So you factor out, and then once you have a factor out, you just set each one equal to 0, and that's how you get your answers. All right, let's go ahead and try another one here. So on this one, again, you know you could use the zero factor property because we have more than one y. And it's not equal to 0, but we can make it equal to 0 by throwing these two numbers to the other side. All right, so if I do that, I have 2y squared. I throw that y to that side, so it becomes negative y. I throw the 6 to that side, it becomes a negative 6. Now we're going to try to factor this out. So again, just like I did, right, we already know how to do this. To factor trinomials, I find two numbers that multiply to 2 times negative 6, which is negative 12. So what are two numbers that multiply to negative 12 and add to the number in the middle, to negative 1? So two numbers that multiply to negative 12 and add to negative 1, that's negative 4 and 3. So I put those numbers in here, and you're like, oh my goodness, what is that? Don't worry, right? So you already know what to do. I put y minus 4 and y minus 3, because remember, this is how, oh my goodness, that's how we factor out polynomials or trinomials, right? Again, why a negative 4 and a positive 3? Because when I multiply it gives me negative 12. And when I add a negative 4 and a positive 3, I get that negative 1. Okay, so that's how I factor it out. And then remember, in order to factor it out correctly, you always divide these two numbers by the number in the front. So the number in the front is 2. I divide by 2. So again, that's where I'm getting these fractions from. Don't freak out. Now, 4 divided by 2 gives me this little 2 here. And 3 divided by 2 gives me a decimal, so don't worry about it. We just leave it like that. Okay, so hopefully you're good. You're still with me up to that point. We're almost done. Now that you factor out, remember the last thing you have to do is you get this one, you set it equal to 0, and you get this one and you set it equal to 0. So that's how I get my final answers. So look at this. I get the first parentheses, which is y minus 2 equal to 0. How do you solve this? You throw the negative 2 to this side and it becomes a positive 2. So that's how I got that answer. And same thing, I grab the second parentheses, which is positive or y plus 3 over 2. And don't let it freak you out. I know it's a fraction, but it's the same thing. How do you leave the y by itself? You move this to the other side and it becomes negative 3 over 2. So those would be your two answers. Please do not give me the answers in decimal format. You would just leave them as a simplified fraction. All right, we are going to do one more here and then we're going to cover the last part of this section. So again, you have this problem. We already know how to do it. You have more than two x's, so that means we're going to use the zero factor property. But of course, it has to be equal to 0, so I'm going to have to throw this little number to that side. So I end up with this, negative 2x squared minus 16x plus 66 equal to 0. Now, of course, we already know how to factor this out, right? We have to do the first number times the last number. But I'm going to stop you here real quick. When you have these problems, I know the 66 is a big number. So what we can do is that we can factor out the greatest common factor first. which is what I did here. Okay, so the negative 2, we're going to factor it out because all those numbers can be divided by negative 2. So this gives me x squared. Negative 16, if I factor out the negative 2, gives me positive 8. And if I factor a 2 out of 66, 66 divided by negative 2 is negative 33. Why in the world did she do that? Just to make your life easier, because now we just have to factor out these little numbers. Okay, so in order to do that, let's go ahead and just do it here. This number is a 1. So what are two numbers that multiply to negative 33 but add to positive 8? So those two numbers are 11 and negative 3, right? Let's try them out. 11 times negative 3 gives me negative 33. And 11 plus negative 3 gives me positive 8. And again, the negative 2, I just brought it down. All right, so what I do from here now, and you see how that was much easier, because if I would have factored out from the beginning, I would have to multiply 2 and 66, and that would have just given me a bigger number. So if you can factor something out first. Now from here, I divide these numbers by the number in the front. Remember, the number in the front, we no longer use this one. We use the 1 here. So do I really have to divide by 1? No, because it's just going to leave the numbers the way they are. So all I do is just set these numbers equal to 0. And that's how I get my final answers, right? So x plus 11, I set it equal to 0. X minus 3, I set it equal to 0. I don't have to set this equal to 0 because it's just a number. If it would have had an x, we would have set it equal to 0, but it's just a number, so we don't care about it. So what's my answer for this? Move the 11 to the other side, I get negative 11. I move the negative 3 to the other side, and I get positive 3. And that is how I get my answers. All right, you have made it to the last part of this one, right? So like I told you, to solve a quadratic equation, there's 3 methods. The first one, the square root property. The second one, which was factoring. And now we're going to tackle the quadratic formula. So if you want to solve a quadratic equation, you are going to have to know this, which again is in our formula chart, and you are going to have it on your notes. Just as a side note, and this is the cool thing about the quadratic formula, it might look scary, you might not want to use it, but the quadratic formula can be used to solve any quadratic equation. So all the equations we've worked on up to this point could have been solved using the quadratic formula, but a lot of students like to leave the quadratic formula as plan B, right? They just use it if they have to. So again, you could use the quadratic formula whenever. So if there's a problem you just can't figure out and you're like, I forgot how to factor out, I don't know what to do, the quadratic formula is going to be your best friend. So what you're going to do is that you're going to put your equation in order. When it's in order, the first coefficient is going to be A, the second coefficient is going to be B, the constant is going to be C, and you're going to use the formula here. Every time you see an A, you're going to put A. Every time you see B, you're going to put the value for B, and every time you see a C, you're going to put your value for C. Of course, just like any other problem, the equation has to be equal to 0. All right, so we're just going to do 2 problems using the quadratic formula because they could get messy, but let's just go ahead and see how they work. So look at this problem here. Again, you see this on your test, you have no idea what to do. So I'm going to show you how to know that if you have to use the quadratic formula. But again, the quadratic formula is always going to work. So if you just want to go straight to it, go for it. First thing you should notice is that this equation is not equal to negative 3 to the other side, and it's going to become positive 3, and we're going to be left with a 0. Now from here, you should notice that we can use your A, your B, and your C. Some of you are going to catch something that I missed here, right? I could have factored out the greatest common factor first and then use the quadratic formula. And I'll show you how to do that in a bit. But right now, let's just go ahead and see if we still get the same answer. So A is your value for the first coefficient. Remember, they're in order. B is your second one, and you do use the negative. And C is going to be the 3. Okay, so those are my A, B, and C values. Now all I do is put them into the formula, and I know that looks very scary, so let me show you what I did. For B and the B here, I put negative 12, so that's how I got these little B's right here. For C, I put a 3, so on this little C right here, I put a 3. And then where we have an A, I went ahead and put the 3. Okay, so I put the 3 here and the 3 there. All right, if you notice, this little negative comes from the formula. This little negative here comes because B was negative. So sometimes you will have two negatives right off the bat. Okay, so please make sure you don't forget that. Okay, so this right here looks very messy. I'm going to show you how to break it down slowly. If you have two negatives outside, this becomes a positive, so positive 12. And now on the inside, you tackle these two separately. Always do this one squared first, so negative 12 squared. And if you put this in your calculator, make sure to put the parentheses because the negative, when you square it, becomes a positive. And then here you do negative 4 times 3, which gives me negative 36. And then in the denominator, I just do 2 times 3, which gives me 6. Okay, so hopefully you made it with me to this point. Now after this, you tackle whatever is inside the radical. So 144 minus 36 gave me 108. Okay, hopefully you're still there with me up to that point. Now from here, what you do is that, again, you have to simplify this, just like we did earlier today. That's an ugly number. If you put it in your calculator, it's going to give you a decimal. So what you do is that you try to break it down. So over here on the side, I'm going to ask you, can 108 be broken down into two numbers with one of them being a perfect square? The answer is yes. 108 is actually 36 times 3. And some of you are going to tell me, oh, 108 is 2 times 54. Yes, that's true, but 54 is not a perfect square and 2 is not a perfect square. So you have to try again until you find two numbers that are perfect squares. Since the 36 is a perfect square, the square root of 36 is 6, so it goes outside. And the 3, since it's not a perfect square, it stays inside. So that's how this became this right here. The 12 and the 6 are still there. Okay, hopefully you're still with me there. Now this right here is your answer, but I'm going to show you how to simplify it. When you have something like this, you always have to check these three numbers. And yes, that was meant to be a heart on purpose. If those three numbers can be divided by a number, you are expected to do that. So 12, 6, and 6 can be divided all by 6. So you divide all those three numbers by 6, you do not touch the radical. So 12 divided by 6 gives me 2. The 6 divided by 6 gives me 1. The square root of 3, I don't touch it. And then the 6, I also divided by 6, and it gives me 1. So if you notice, these little numbers inside the heart, if you can divide them by a number or simplify it, you do it. If you can't, then you leave it as the way it is. But in this case, all of those numbers could be divided by 6. So I divided each one by 6, and that's how I got 2, 1, and 1. Now, hopefully you see how this can be rewritten to that, because when you divide by 1, you don't need it. So I didn't write it down. So my final answer was just this. 2 plus and minus the square root of 3, which translates into two different answers. 2 plus the square root of 3 and 2 minus the square root of 3. Because remember, the plus and minus means we have two answers. All right, hopefully you feel comfortable with that. That's how you do the quadratic formula. All right, just to make sure it made sense, we're going to do one more. Look at this one here. So this one, it's already equal to 0, so that's awesome. It's already equal to 0. Now, before you go on and tackle this problem on your own, remember, in order to use a quadratic formula, it has to be in order, which it's not. In order means that we have the t squared first. The number that doesn't have a t has to go at the end. So I just moved it to the end. It doesn't change sign because it's still on the same side of the equal sign. I just rearranged it. And then the 4t changes places with that one. Now that it's in order, this is going to be your A, this is going to be your B, and this is going to be your C. Okay, and then I just use the quadratic formula, and I'm so sorry, but it's there. And again, I'm just going to show you how to simplify it, right? So I put the A every time you see an A, so right here in these two. The B goes outside and inside, and then the C goes right here. Since remember, since it's a negative 19, it's still a negative 19. The negative here comes from the formula, right? So I know the b is positive here, but the formula says negative b. And then again, like I told you, you simplify this. So negative times the positive 4 gives me negative 4. 4 squared gives me 16. Negative 4 times 4 times negative 19. I put that in my calculator and it gives me positive 304. And then 2 times 4 gives me 8. And then 16 plus 304 gives me 320. And this is where I'm at right now. Now again, this is a big number. If I put that in my calculator, it's going to give me a decimal. So again, we have to ask ourselves, okay, 320 is what times what? Can it be a perfect square? Try all the perfect squares you know. So you know 9 is 320 times 9 times something, and so on and so forth. You'll eventually notice that 320 is 64 times 5. 64 is a perfect square. The square root of 64 is 8. So I take out the 8 and the 5 stays inside. And that is how this little square root became. Now I know you're like, oh my goodness, I'm done. I'm tired. That's my final answer. You always check one more thing. Remember these three numbers. Can those three numbers be divided by a single number? The answer is yes. All of those numbers are divisible by 4. So I divide all of them by 4. And just hang on with me, we're almost done. If I divide all those numbers by 4, the negative 4 becomes a negative 1 plus minus 8 divided by 4 gives me 2. And the bottom number, which is 8, 8 divided by 4 also gives me 2. And remember, we don't touch the root. The root is still square root of 5. And then there we go. Those are my final answers. Remember, we have two answers. My first answer is negative 1 plus 2 square root of 5 over 2. And my second answer is the same thing, but with a minus right there. Okay, so this is how you use the quadratic formula. It could get messy, but remember, you could use this quadratic formula for any quadratic equation.